And we're live.
Hello, everyone. I would like to welcome you in a very special webinar in this series of the Learning from the Extreme webinars. I'm really fascinating to watch it with you, as I'm no expert in the field, so I'm just waiting to go all the way to Chile and to see the Paranal Observatory. And without further ado, I'll give the floor to my dear colleague Gustavo Rojas, who's a much more expert, to introduce you to the webinar and to Eleonora Sani in Chile. Gustavo, the floor is yours.
Thank you, Nikos. So welcome everyone to this edition of Learning from the Extremes webinar. I'm very glad to introduce you to our host in Chile, live from Chile, from Paranal Observatory in the Atacama Desert, Eleonora Sani. So welcome, Eleonora. Thank you very much for being here with us.
Thank you, Gustavo. Thank you for the nice invitation and for the opportunity to connect.
Excellent. So we have a very different activity today because Eleonora will show us the observatory, both the control room where she is now, and she will explain what kind of work they do there. And then a bit later, she will show us how is the outside of the observatory where the telescopes are located. So this will be the first half of the presentation. Then Eleonora will have to leave us because she's very busy. But I will continue then showing you how you can make your own virtual visits, not only to Paranal Observatory, but to all the other ESO facilities. That's a very nice feature that is available for everyone on ESO website. So that's our program for today. So Eleonora, again, thank you. Good morning, because it's still 10 o'clock in Chile, right?
Correct.
Good. So thank you, and I'll pass you the word, and we will relay you the questions. If the questions come through the chat, sure. We will pose the questions for you, okay?
Thank you very much, and good afternoon to you. Nice to meet you. And welcome to Paranal Observatory. So I'm, as Gustavo was saying, I'm Eleonora Sani, and I am an astronomer at ESO. And my charge is to coordinate the work of the astronomers, in particular for the performance of the instruments. And I am also a deputy head of Science Operations Department here in Paranal. Right now, I am on duty. I am on a shift here in Paranal, and I'm covering for a role, a special role, a very important role that is called shift coordinator. Basically, I am seated at a control room, control tower, in a sense, for the observatory. We have 4 8-meter telescopes to operate. We have 4 small telescopes called auxiliary telescopes, 2 meter wide, to operate at night, plus 2 survey telescopes of 1 of 4 meters and 1 of 2.5 meters. And all of this implies a lot of activities during the day. It implies monitoring the systems. It implies for the engineers to go back and forth from the telescope, do all the maintenance that is needed, and if needed, if something happens, to recover the systems. And all of these activities during the day needs to be coordinated. Plus, consider that our systems are all prototypes. There is nothing else on planet Earth that is the same. No, so we need, from one side, very specialized people to work on this, and from the other side, to constantly monitor what's happening, so that if something misbehaves or some issue happens, we can react immediately and deliver the system working at night. So where I'll turn my laptop so you can see my working station. So, okay, I have, email inboxes for the tickets as well that we do receive. And I have monitoring systems for all the status. Sorry, this is maybe a bit too far, but I have green flags, red flags, depending on the statuses of the various systems. And I can give a look to the weather overall in the observatory and to forecast. In this moment in particular, we have high wind. The wind is about above what is called the pointing restriction for the telescope. It is above 15 meters per second, which corresponds to about, if you make the conversion, 54 kilometers per hour. This does not, if we were at night, this would not allow to the telescope to point in certain direction, to point against the wind. And during the day, it also limits operations. I will show you later. First, let's make a tour indeed of the control room. Let's go with me. So here you can see our control room. There is one working station per unit. And right now we'll go to Unit 1 and Unit 2, also known as Antu and Kuyen. So I'll leave my laptop here so that you can see the unit. Okay, so we have, I make a panoramic. So we have their instrument controls are there. From here, we do manage the queue of the observations at night. And we do monitor also the telescopes. And these monitors are indeed to monitor the sky and the weather conditions, so that the operators and the responsible for the safety at night can take decisions. It's on a single person, for example, to take decisions whether the conditions are good enough to observe and which level of transparency of the sky we do have, if it is photometric, so excellent conditions, if it is clear, if there are fixed cirrus, if there are fixed cirrus. If we have to stop pointing in certain directions because of the wind, there is what is called weather officer, and this person at night tells to the entire observatories, you cannot point in this direction anymore, or there are thick clouds passing by. And the astronomers and the telescope operator using this console, they do have dedicated tools to select properly observations that can be run at night. Because depending on the scientific scope of an observation, not everything can be done depending on the conditions that we have, okay? Only certain kind of observations can be done if we are, for example, if we have thick clouds. During the day, what do? We do receive a handover from the nighttime crew that tells us if and which kind of issues or difficulties they had, and we follow up on the status of the recovery of the systems. In addition, we do run a series of calibrations on the instruments. Why this? For two reasons. One is that to be used, the scientific data need to be cleaned by a series of effects that are given by the atmosphere, or also instrumental noise given by the instruments themselves. Okay, so to be able to do this in the processing of the scientific data, we do need to collect calibrations that are taken with lamps that are mounted into the instruments, okay? And we do deliver this data to the users. Moreover, we take, with those calibrations plus, let's say, technical calibrations, we do make measurements that give us an insight on how, on what is happening to the instrument, if the instrument is behaving, if it is behaving from the scientific point of view, or maybe something is going wrong. And so we can take action to recover it. And now, I don't know, maybe there is some question, I see.
There are no questions, but there are people
Okay.
greetings from their locations. So we have people from India, from Romania, from Brazil. So we have viewers worldwide.
All right. Thank you, everybody, for joining. It's a pleasure to meet you. I don't know if I shall summarize since people were still coming, or move forward.
No, please move forward.
All right, okay. So we move a bit more so I can give you an idea of how big is our control room. So as I was saying, with these consoles, we do control 2 unit telescopes. And we can do that at the same time. Let's say the operations for those two telescopes are, in a sense, merged. Then we have another working station here for the Unit 4 telescope, also known as Yepun, which is, let's say, one of the most complicated systems that we have here, because it can work in what is called an adaptive way, so to correct for the turbulence in the atmosphere that alterates the quality of the data. Moving again, here we have the two survey telescopes are operated, one from this part of the room and one from this other part of the room. And then here we have another one, possibly the most complicated system that we have here in Paranal. All of these panels, all of these consoles are used to operate what is called the Very Large Telescope. The Very Large Telescope works in interferometry. Interferometry means combining the light that comes from either the 4-unit telescope, the 4-8-meter telescope, either from the 4 auxiliary telescope. So in this part here, you can see the control of the 4 telescopes, while in this central part of the unit, there is the control of what are called the delay lines. The delay lines are a system of galleries, of tunnels, where optical elements are installed, so to allow for the combination of the light from the various telescopes. And once the light, and thanks to these delay lines, the line is converged into a laboratory, there is combined, and then we can go ahead with the scientific observations, which is run from one of these 3 consoles. Consider that for each unit telescope, as well as for the Very Large Telescope interferometer, we have 3 instruments. For the survey telescopes, we have 1 instrument each telescope. Currently, not all the foci of the telescope are occupied, so we have 16 telescopes operating. And these 16 instruments, sorry. And these instruments can be selected at night depending on the observation queue that we have, on the scientific priorities that we have. I don't know if there are questions right now on how we do operate, how we are organized here in Paranal.
Yes, there's a question here already that how many people work usually during the night, because now the room is quite empty, but during the night it should be very crowded. So if you could please explain that, and also what kind of professionals work. It's not only astronomers, right? You have engineers.
Absolutely.
And other. So yeah, please.
So on average, on the mountain, we have 120, 130 people. Okay. Most of them work during the day. Most of them are engineers. And engineers right now are spread through the various units to maintain the system, so to work on maintenance activities or to interventions to recover. Today is quite quiet indeed. As astronomers, we are on average 20 more or less in the mountain. And at night, the crew, depending on the activity, is of 12 people, 16 when we have verification activities, what it is called commissioning activities. So that means the verification of the instrument at night. During the day, beyond me as a coordinator, I have two colleagues that helps me to monitor indeed the systems. Okay, and right now they're around, but they are a bit shy, so I'm not going to be shown on camera. But right now in the control room, we are actually moving from one place to another. We are 4 or 5 people. We have also some IT colleague, maybe from a distance. I can show something.
Yeah, there's someone in the background. Yeah.
Exactly.
Great. Eleonora, there's another question here from Kodali asking what the images from these telescopes, which the format is it recorded? Because it's not like a regular image file, right?
Correct. So the format is what is called a FITS file. The FITS file contains the information that is recorded. So light reaches the telescope, is diverted to the instruments, and from there it reaches the detectors in the instrument. The detectors are basically chip that conceptually are not that different from the chip of our cameras in the cell phones, okay? That signal is read out by the electronic, it reaches a machine, a computer, a working station, and there it is merged with all the telemetry of the telescope and of the instrument that then is useful, is needed actually to reduce the data. So the image, let's say the information from the detector and all of this telemetry called also header are merged together in a single file that is then delivered to the user. So this header, for example, contains the coordinates, where we were pointing, the conditions of the sky, the setup of the instrument, the mode using the instrument, the wavelength, etc., etc.
Great, thank you. There's one more question, and then I think we can move outside, perhaps, because it's already 18 minutes past the hour, and you have other commitments. It's Mert is asking if you have work for teachers and students in the observatory. You know, our audience is mostly teachers, so if you can say something about it.
So in the sense, if there are positions, working positions, you mean?
Yeah, I don't know. It mentions work, but maybe activities or something, not positions.
So activities, we do have, the observatory opens every Saturday to the public. So also schools, of course, can come and visit every Saturday morning. It is free, but the group has to reach independently the observatory, and the visit can be booked on the web. There will be a guide that will bring the group to the control building and also to the telescope domes. In terms of, let's say, if one is interested to possible working positions, in terms of here at the observatory, no, but there are often journalism's masters for journalists, so communication, and we have the communication department that at times can open positions that maybe might fit more with the profile of a teacher. And also the planetarium. If in case the teacher, correct, with planetarium in Garching in this case, the supernova museum with planetarium that is located in Germany, to our headquarters in Germany, but yes, for sure. If the teacher, in case, is a physicist or astronomer, so with a scientific background in these fields, then positions for astronomers are also opened, or engineering positions as well for engineers. Good. Thank you. Eleanor, I don't know if you want to go to the platform now. If you think it's nice and interesting for you, to me, it takes like 3 minutes. I think everybody's dying to see that. Everybody wants to see outside as well. So do you have to disconnect or? I have to disconnect because in the path, I don't think to have enough signal, and I will connect with a cable from there. Okay, so maybe, I don't know what's better. I quit the call and reconnect. No, just stay here. If you miss you just rejoin, and we will do for you. So I'll show you what I need to go outside. Of course, I need a jacket. Remind that it's more than 2,000 meters above sea level, so it's a top of a mountain. The top of the mountain is 2,700 meters, and I need to bring a radio with me because I'm a contact point, so I need to be contactable, reachable. And also for safety reasons. If something happens to me, I can call for help. So right now we are in our corridors. Still signal, that's good. Okay, now the signal froze, so probably going to stay without Eleonora for a while. Okay, we missed you for just a few minutes, but okay, we have you back. Really? I'll disappear again. And thank you. I'm going outside right now. and I guess you'll miss me. Okay. So you start to feel the wind. Okay, I am on the platform right now, and maybe you can see a bit the panorama.
Okay, we are having connection problems, but we'll probably have her back in a few moments. So as you have seen, Eleonora went outside and you see blue skies, typical of the desert. So let's wait a bit more to see if we have Eleonora back. She probably missed connection. So meanwhile, I'd like to thank you all for following us here. We'll ask the questions that when we have Eleonora back. But she probably, yeah, she's coming back now. Okay, so yes, Eleonora, welcome back. You're muted, so you have to unmute yourself. Please turn on your mic. Maybe I can do that for you. Oh, sorry, I muted you accidentally. Yeah, now we have you.
Okay, no problem. So I am reaching a nice place, let's say, in the platform, but in the meantime, here are telescopes. So let me. I might miss the signal again because I'm reaching the cable, but it's going to be more stable for sure.
Good.
So
no, we have you. Yeah.
On my back, you can see one of the units again. All right. Let's see. Can you hear me?
We can
Hello,
hear you.
hello?
Yeah. Yes. Now it's good. Okay. Great.
Okay. So let's see. So okay, if I turn a bit my laptop, you'd be able to see the unit telescope. This part of it, the camera is not that wide. This is unit telescope number 1. A structure that you can see is used for when the mirror comes out from these gates, lateral gates, there is a support and then it is lifted down and brought in the illumination station. So that's why you see that structure there. The mirror is about to be recoated. Then here we have UT2, Unit 2, and Unit 3, and Unit 4, and the survey telescope. And you see also some colleagues passing by with helmets and so to go for their work in the domes. If you have any questions, just ask me. There on the background, we can see also the very small telescopes that are used with all sky cameras to measure the transparency of the sky. And nearby here, just on my side, this building is the laboratory with the tunnels that I was mentioning where light is combined. As you can also maybe appreciate, there is not only wind, but a lot of light. I am barely able to keep my eyes open, and almost every day we have here an ultraviolet, let's say, very high level. Indeed, we do protect ourselves with sunscreens and glasses. I should have my glasses, actually. To be quick, I forgot.
Amazing. Yeah, people
I don't know
are
if
just,
there are questions or any curiosity.
Yeah, people are saying just wow and thank you because I think they are amazing. I've been there a number of times, but the first time you see it is really impressive. There are a couple of questions here, Leonora, about how is the telescopes, how they are operated, if they are automatically, and if they can be used in remote mode. Can you tell us something about it?
Sure. There is a limited amount of telescopes that are used with automatic. Then here we have unit 2, unit 3, and unit 4. Unit 2 is used for very high level. Indeed, we do protect ourselves with sunscreens and glasses. I should have my glasses, actually. To be quick, I forgot. of operations that we can do remotely, for example, from Santiago de Chile, where the other headquarters of ISO is. In this case, we can operate the instruments, so we can set up the instruments, we can take images remotely from the instruments, but we cannot move the telescopes. So we could not fully operate at night without telescope operators here, at least. This is for safety reasons at the moment.
Good. And you mentioned the light, the sunlight, and the wind. And I must say also that is a very dry environment as well. So you also need to have lip balm and other things. It's a very hostile environment, right?
It is a very hostile environment. Indeed, the humidity right now is around 10%, the relative humidity. It can drop down to 3%. So, as you were saying, we have to irritate ourselves a lot. We need protection for our screen. We need teardrops, lip balms, etc., because otherwise we could not live here. We could not operate. Also, the low humidity, the dryness, and the high ultraviolet radiation degrades the material here way faster than in our cities, than in normal places. So, for example, all the junctions, all the closing gates that are made of soft plastic and stuff, they need to be replaced with a higher frequency that normally happens because of this faster degradation due to the extreme conditions that we do have here. Yes, absolutely. Consider that the dome of a telescope up to the top is high 30 meters. So if here at the level of the platform we have 55 kilometers per hour of wind, there it's a bit higher. So I think right now it's 10 kilometers per hour more. So the kind of stress that and it can reach, we have to stay close in that case, we cannot operate, but it can reach 120 kilometers per hour. So these structures so high to resist that amount of stress, which is pretty impressive.
It's really impressive, and the kind of engineering that is required for this work is really amazing. Eleonora, I don't know if it's 10 for you. I don't know if you have to leave us all.
I can stay like 5 more minutes. I have my radio. If they need me, they will call me.
Okay, good. We have a last call for our viewers to, if you have any more questions to Eleonora, this is our last chance, and then we'll continue the visit. So if there's anything else you want to say to our viewers, Eleonora, before we say goodbye?
Yeah, sure. Look, I feel extremely lucky in doing the job that I'm doing, in doing what I wanted to do. This is a unique place where to be. It is extreme. It is hard to live here. We spend a lot of time far from our families because we are on shift. We stay here at least 1 week or even more, 10, 12 days. So it's at times a challenge, but it's a rewarding challenge. And the quality of the science that we can get with our facilities is highest that we can have on planet Earth. We got 2 Nobel Prizes, 2018 and 2020, but with our facilities. So this demonstrates also the level of science that we can deliver, and we are really proud of this.
Great. Thank you, Eleonora. So just to let our audience know, your background, are you a physicist? What was your the degree that you had in university?
Yes, I have a master in physics, and I did my PhD in astrophysics. So I'm a doctor. I'm doctorate. Yeah.
Very nice. And there's a final question here about what kind of material is used in the dome, in the metal thing part? Is it aluminum, steel? What kind of material is that? You know?
It's the let's say the structure is I sing it in English, sorry. It's steel, and then aluminium on the outside, indeed, yes.
Okay, so it's metal, it's light, but also very resistant.
It's metal, and the basement is cement.
Yes,
and also it has to resist earthquake. But here in Chile, we can have earthquake. I mean, everything has been built to resist till an absolute magnitude of 9 for earthquakes.
Yeah, so that's also very interesting to mention because it's a seismic zone, and yeah, all this has to be really very well resistant to earthquakes. Okay, Eleonora, we don't have more questions here, just people thanking you for the opportunity and the exciting broadcast here live from Chile, from Paranal Observatory. So in the name of our collaboration of the Learning from the Extreme projects, I'd like to thank you very much for having some time to present the observatory to us, and wish you all the best in your work and success in your career. And thank you also for making this opportunity possible.
Thanks a lot. Thanks for the invitation. It's been a pleasure, and hope to meet you again.
Okay. Thank you. Bye-bye. Ciao.
Bye. Ciao.
Okay, so how about it? I'm thrilled. I've been there before. I'm fortunate to be there in Paranal a couple of times before, but nothing beats like seeing it live from Chile, and our audience really thrilled. We will continue our visit. Leonora, if you want to stay with us, you are welcome. But what I want to show you now in the second part of the visit is that you can continue exploring the observatory on your own using ESO's website. So I'm going to share my screen now so I can present you some of the features. So just give me a brief moment while I share my screen. So first of all, you have to visit ESO website, which is eso.org. So Nico, if you please can copy the URL in the chat so people can have the address. So it's eso.org. So that's the main portal. ESO is the European Southern Observatory, and is an international collaboration that has 16 member countries from the European continent, and also 2 additional non-European countries that are partner countries. One, of course, is Chile, where the telescopes are located, and the other one is Australia. So this means that all this information is also available not only in English, but also on the national languages of each one of the countries that you see the flag. So I speak Portuguese, so I can go to the Portugal flag and then have the information in Portuguese. So that covers many different languages if you are not very familiar with English. And in the website, you have lots of interesting information. You know, you have press releases, you have images, videos, and plenty of other cool astronomy things. Some of the best images in the world of space are captured using ESO's web telescopes, so you can access it. But what I want to show you is how you can make your own virtual visits to the observatory. But before that, I want to show you the live webcams. So Eleonora just showed us the view, the live view from the observatory. But if you go to the outreach section of the website, you will see this option here in the middle, that is webcams. And in the webcams, you can see different live images from the different ESO sites. So right here is an image from where Eleonora was talking to us. So this is put on a different vantage point. So it's a bit higher, so we can see the surroundings of the observatory. So Eleonora was talking to us more or less from this angle. So recall, you have the building here, and also this structure. So this is a temporary structure that is used when the engineers need to remove the main mirror of the telescope and then bring it down the mountain to make the maintenance and reillumination of the reflecting parts of the telescope. So this is a very large mirror. It's more than 8 meters in diameter. So you can imagine the complexity of the operation and how delicate it must be, because we know mirrors are very fragile. So the main mirror goes outside in this yellow structure, and then it's put on a truck, and then goes down the hill to the workshops that I will show you in a moment. So you can see these images. These are not live images, but it was like 1.5 hours ago. So this is constantly updated, and you can move your camera using the arrow keys or the mouse, and you can move the image and see the other parts of the platform. So as Eleonora was explaining, we have 4 unit telescopes, which are the large ones. And then on the back, we have a smaller telescope that is used for wide field imaging. And to that side, we can see the mountains of the Andes, of the mountain range that runs through all Chile. And we can see how dry this place is. So Eleonora was mentioning that the average humidity is below 10%. It's a very harsh environment, but also that makes perhaps one of the best locations for ground-based astronomy in the world. Here in this view, you see those round domes. These are the smaller telescopes that are used together to have the very large telescope, the interferometer, operational. So they can be moved. So along these gray tracks here, it's possible to reposition those smaller telescopes and have the configuration needed. So this is very nice. I think you can explore not only the view from Cerro Paranal, where Eleonora was talking to us, but also other places that are operated by ISO, including this one that this is the mountain where the next large telescope will be built. So this is Cerro Amazonas, which is a different mountain that's like 20 kilometers from Cerro Paranal, where the new large telescope is being built, is the extremely large telescope, and this will be the largest telescope on Earth, optical telescope. The mirror will be almost 40 meters in diameter, so that's 5 times larger than the ones that are currently in operation in Paranal. So this project started 5 or 6 years ago, and it will be ready in 5 years. So there's already parts of the structure ready, the base of the building. And this crane here that can be seen in this image is 120 meters high. So it's like the size of a 40-story building. So that will be impressive. And this will be the final height of the new observatory dome. So we hope that in a few years we have this instrument ready. So you can visit all these amazing webcams in ISO website. Remember, in outreach, and then webcams, and then you can see all the other live cams from ISO. But what I'm going to show you in this final part of the webinar are the virtual tours. Nico, if you have any questions, you can interrupt me. So we are now more in a controlled environment. So if you have questions about not only what I'm presenting, but also about the telescopes, you can make it to me as well.
Yeah, well, not for the moment.
Okay, thank you. So the results I want to share with you, and I hope the teachers can also show it to your students, are the virtual tours that are available in ESO website. So this is located in a different part of the website. It's not in outreach, but is in products. And then is in the first part of the menu is the last option that's called virtual tours. You see, there's so much in the website that you can spend days here seeing all the material that is available. But then the virtual tours, you have two kinds of products. One is the 3D panoramas that you can explore using virtual reality headsets. Can be like your smartphone and use glasses, or full VR headsets if you have available. So you can click on this, and then you have image that is a 360-degree panorama, and then you can move your head and see like in an immersive interface that you can explore. There are also stereoscopic images, so that has like a 3D feel, but you need to have those glasses to explore these VR panoramas. But the one that I want to show you are more ordinary 2D resources. You see this on the bottom part. We have the virtual tours in all ESO facilities. So I must say that ESO is not one particular observatory, but is a set of observatories. The oldest one is La Silla. This was the first observatory that was built almost 60 years ago, and is located near the town of La Serena, in the southern part of the Atacama Desert in Chile, which is roughly 500 kilometers north of Santiago. So you can explore this older observatory. It contains dozens of telescopes in this tour. You can also visit Shajnator, which is the site where ALMA is hosted. You know, ALMA is an array of radio telescopes that are located at a very high altitude, in 5,000-meter altitude. It's an array composed of 66 antennas, if I'm not mistaken. And is a very unique observatory that is operated by ESO in collaboration with other countries in North America and Asia. So you can also explore ALMA in this virtual tour. You can visit the headquarters of ESO in Garching, near Munich, in Germany. Also, the headquarters in Santiago, in Chile, and the Supernova Planetarium and Visit Center that is also in Garching, near Munich. But we are going to explore the observatory that we're just visiting with Eleonora, which is the Observatory Paranal, and also Amazonas. So when you click on the tour, you are automatically taken to this window here, which shows the platform. So this is a view that just like the one that you were seeing with Eleonora. So we have a panoramic view of the surroundings of the observatory. You can see this is a totally dry place. You know, there are no vegetation, no plants whatsoever. And this is not a live image, this is a static image, and you can see the observatory domes and the smaller auxiliary telescopes, the tracks that I mentioned, that these smaller telescopes can be moved around these tracks. And you can see also these blue balls here. These are is a hotspot. So when you click in one of these blue balls, you are taken to this location. So in that way, you can explore the observatory at your own pace, at your own will. So I clicked inside the telescope for hotspot, and we are taken now to the inside the dome. So this is how the telescopes look from inside those shiny metallic structures that we were seeing from the outside. So CEST is one of the main 4 large telescopes that are located there in Paranal. It's a 8.2 meter main mirror telescope. You can see the mirror here on the bottom of the image. You see this reflective surface. It looks small, but it's more than 8 meters across. It's one of the largest astronomical mirrors in the world. And it's a single piece of mirror. It's not composed of segments like some of the more modern telescopes are built now, like James Webb. You see it's composed of segments. This is a monolithic piece, is a single piece of glass coated with a reflective surface. And this is the one that will be removed to be re-illuminized, as Eleonora told us. So you can explore the building. We don't have much time to tell you all the details. That can be part of our second broadcast later, to explore in detail these telescopes and structures. But what I want to show you is, I think it's a very interesting part that is not very common people to comment. That is where the astronomers live and where they spend their time while they're not at the control room or at the telescope. So that's what I'm going to show you. So this is the virtual tour in ISO website. And if you go here to the bottom of the screen, you have several tools that you can move the image, zoom in, zoom out, pan, and you can also show the map here. So this map provides us a bird's eye view of the observatory. And I'm going to share with you, like if we are just arriving at the observatory. So here, this is a satellite image and show us the location of the observatory in the Atacama Desert. So you see there's really nothing around. There are no cities. So the closest main city is Antofagasta, which is like more than 100 kilometers to the north. So that means that the sky is very dark. There's no light pollution. It's a desert, so there's not much to see around. And when you are visiting the observatory, you usually fly to Antofagasta and then go by car to the observatory. So when you arrive, this is what you see. There's a gate, of course, and where you have to identify yourself before entering the observatory. So this is, if you go to Paranal visit as an astronomer or as a visitor that you can visit on Saturdays, is open to the public. This is what you will see. You will see a gate with where you have to identify yourself before being allowed inside the observatory. And we can see there are 2 main structures. We have close to the gate the living quarters and the workshops and all the infrastructure that is needed for the astronomers who live there and the engineers. And there back in the top of the mountain are the telescopes. So there is a road that connects the living quarters and workshops up to the mountains, roughly 3 kilometers from the gate here up to the mountain. So you usually take a car to go up the hill, because it's a very dry place. It's in the altitude, so there's less oxygen. So people usually take a car to go up the mountain. But if you want, you can walk, and it's roughly 30 to 40 minutes walking up the hill if you feel like. So we see here many different buildings, white buildings in the foreground. I want to show you first the building that is used for re-illumination. So I think it's this one. Also, this is a working station. So you can click in any of these hotspots, but this is where the mirror will be taken to. So this is the workshop that is used for the maintenance of the main mirrors. So each year there's a time of the year that the mirrors are cleaned. You can imagine it's in the desert. There's a lot of sand and dust, and the mirrors will gradually become dirty. So they need to be really washed with water, and then a new a new layer of reflective material that is usually aluminum is coated in the mirror cell inside a vacuum chamber. So all this work is done in these workshops. So we have several different images here from this structure in the observatory. So this is the machine that makes the cleaning. It's like a washing machine, dishwasher. You have that thing that turns around and throws water. So it's more or less like washing a dish with all the necessary cautions that you need to handle with such a delicate thing such as a telescopic mirror. So this is one of the structures that you find on the base of the mountain. Another one that I want to share with you is that there is a gymnasium, there is a sports court, because as Eleonora said, there are more than 100 people at the site all the time. We have engineers, you have astronomers, you have the maintenance people, you have cooks, you have people who take care of the living rooms. So it's really a community, and they go to the observatory and they work in shifts. So they need to stay there for usually 1 week to 2 weeks at a time, and then they go back to their home. So it's like working on offshore platform or someplace that you need to spend some time. You don't go to your home and back to the job every day. So you have to live there for a while, and then you need all the structure that you usually have near our own home. So this is a sports court where the people can play sports. They can have some kind of leisure while they're not working. So this is the kind of structure that you find on the outside. And if you go outside, that is the view from the workshop part and also the leisure structure. Now we are going to move to the hotel. So this is another structure that I really like to show because it's very unique. So this dome here that you see is part of the residencia, which is the astronomers' hotel in the observatory. So the engineers and the astronomers and also invited guests, they stay at this very different structure that is like half buried in the desert. This was a building that was designed by an architect that received several accolades for this project because it merges with the landscape. So it's not a building that pops out of nowhere, but is integrated in the landscape. So usually the access is done via this ramp, and when you open the door, you'll see the inside. So they have created a tropical panorama inside this building. So when you enter the residencia, you have a place that is very humid. So you have the swimming pool, you have the plants, and that brings humidity to the air, and that makes things more tolerable. It's much better than outside in the desert where the air is very dry. So here you are in a more pleasant atmosphere, and you can feel less stressed of being in the desert. Here you can forget a little bit about the harsh environment outside. So this is the first view that you have when you enter the residencia. So this is like a hotel. You have a front desk with someone that will give you the key for your room and also tell you the whereabouts of this building. There is a living room, and you have other kinds of facilities. You have a movie theater, you have a studio. If you play musical instruments, there's a small music room with drums and guitars and keyboards that you can get there. And if you go here, you have the most important place in the whole observatory, which is the cafeteria, is the restaurant. Astronomers usually like to eat, and everybody likes to eat, I think. And it's very important to have the scientists, astronomers, everyone else well hydrated and well fed. So this is the cafeteria where the meals are served. There is always water. There is always fruits, bread, and something that you can grab if you feel hungry. So here are some nice fruits from Chile, some bread, and during the meal hours, regular courses are served for breakfast, lunch, dinner, and supper. So it's like a restaurant. People can go there and eat. And back here, you have the refrigerators where you have cold drinks, also soft drinks, juices, and ice cream. So this is one of my favorite places in the observatory, is that somewhere around here, it doesn't show up in the photo, but there's a ice cream machine operated 24 hours a day. So if you like ice cream, you can come here and have a cone whenever you like. Don't overindulge, because then you get fat, but it's always nice to have some nice ice cream here at the cafeteria. So this is a place here inside the residencia. And the living rooms, they are located on the other direction. So here we are looking at the cafeteria, as you might recall. To the other side here, through this corridor, you have the living rooms. So there are 3 stories of rooms. I don't recall how many exactly rooms we have, but I think it's around 70 rooms in this building. We are going to enter a room very soon. But this is a very quiet place, because there will be always people sleeping. If you go during the day, chances are that the astronomers that work during the night are sleeping. If you go during the night, probably the engineers who do the maintenance are sleeping during the night. So silence is mandatory here, so you don't disturb the other people. There are also some gardens inside, so people can just relax here in these more private areas. And you see the doors of the living rooms. And how does it look, the room from inside? We will see that now. So this is the typical room in the residencia. It's not very luxurious, but has the essentials. They usually don't spend much time here. It's just for sleeping, maybe do some work, but there are other offices that you can work if you want. So you have a bed, you have a desk for work, and maybe use your computer or do anything else, a little chair, and this door here takes you to the outside. We're going to show you very soon. And here you have a private bathroom and closet. So as I said, people work here in shifts. So usually when you go to a room, this room is being used by someone regularly. Every 2 weeks, 3 weeks, this person comes and uses the room. But while the person is not there, the room can be used by a second person. So when I visit Paranal, I was there 3 times. I used a room that is usually inhabited by someone for the ESO staff. So there are personal belongings, and the room is also disclosed. This closet is locked with the belongings of the person who usually uses it. There are some books and other things, but if it's a visitor or just a regular visitor that goes there for 1 or 2 nights, it can use the room for the other people. And then one nice thing is that if you stay in the ground floor, you can open the door and go outside. So that's what happened to me. So it is how the residential looks from the outside. So we can see all the different floors of the hotel. So each room has its own access to the outside. It can be a terrace. It can be just walking into the desert. And you can spend some time outside if you want. So this is a view from the sunset. And just to mention here, and I'm almost finishing this tour, is that this building is, if you like movies and if you like James Bond movies, this was used for filming the movie Quantum of Solace. That is a James Bond movie that's like 20 years old, probably more. But this was the hideout of the bad guy, the villain. Yeah, this was the setting for the hideout of the villain of the Quantum of Solace movie. And in the movie, this thing explodes, but it's just special effects. The building is still there, is the hotel from La Residencia in Paranal Observatory. So there's a lot of more to see in the virtual visit. I just want to end with this beautiful image of the Residencia during night. So if you are happy, if you're lucky enough to visit the Atacama Desert by night, you'll probably see something more or less similar to that. So it's in the Southern Hemisphere, and the Southern Hemisphere, we have the Milky Way running directly through our heads if you are in the latitudes of the tropics. And the center of the Milky Way is also very high in the Southern Hemisphere. So that's why is one of the reasons of why the observatory was built in Chile, is to have access to our own galaxy and also our neighboring galaxies, the large Magellanic Cloud and the small one that we can see here in this image. So here is the large one, and here is the small one, and here the fantastic Milky Way. So if you are lucky enough to visit, you please spend some time outside and marvel at our universe. And that's what people at ESO do every night, working round the clock to reveal the secrets of the universe. So I'm going to stop sharing and maybe end this virtual tour. If you can all explore these resources in ESO websites, there's a lot to explore, a lot to learn. And maybe share this with your students and maybe encourage them to become an astronomer in the future. So, Nikos, I think I'm done. Are there any questions or comments in the chat? I think I'm muted.
I'm muted, of course I am. Sorry for that. There are no questions, just expressions of gratitude and for a job well done. It doesn't happen often, but I'm speechless. It was an amazing visit, and I just want to plan my to how I can go there. It was amazing, especially the last picture. I mean, we can only stop and think how small we are. Anyway, Gustavo, I have no words to thank you, and I will find some words to thank the teachers all around Europe and the world that were with us this afternoon. Thank you once again for being here. Keep visiting our website and the portal for the new webinars that will take place. We have next Wednesday, May the 31st. The next webinar is called Teachers as Creators and Designers of Digital and Blended Lessons. And keep posted for the next webinars throughout June. And we will be more than happy to have you along our work. Gustavo, again, thank you so much.
Thank you, my pleasure, Nikos. And we'll be back here next Wednesday with a new webinar. So thanks a lot for everyone who was watching, and thank you for watching this recorded session. Thank you for being with us. See you next